Hi, boys and girls. Welcome to Module 3. Oh, this is so exciting. um, all right, this first section, I kind of thought about skipping this first section, but then the more I looked at it, I thought, well, no, there's some good information in there, and it'll give you a little bit of a break from solving equations, which I think some of you don't love that as much as I do. I don't understand. Anyway, Representing Relations, section 3.1, and this is starting on page 135 in your workbook. You can use math to represent the relationship between two sets of numbers. For example, suppose you recorded the number of minutes you spent driving for your driver's training course each day for a week. You may use the set 1, 2, 3, 4, 5, 6, 7 to represent the days, and the set 30, 45, 20, 40, 45, 90, 60 to represent the minutes. The relationship between the sets pairs each day with the time driven that day. This pairing of the numbers is called a relation. The set of days is the domain of the relation, and the set of times is the range. Okay. So yes, I just read that paragraph to you. This page was humongous. I broke it up into 3 slides. A relation is a set of ordered pairs. The set of the first numbers of the ordered pairs in a relation is called the domain. The set of the second numbers in the ordered pairs in the relation is called the range. Okay, so when you're thinking about, let's say we have, is my pen turned on? Yeah, you know, you're familiar with the XY chart here, like that. These are the X values, these are the Y values. If you have a point like 2, 3, you write it this way, 2, 3. Okay, and these ones are the domain, and these ones are the range. You can think of it this way. X and Y go in alphabetical order, domain and range go in alphabetical order. See if that helps. More words. This book has got so much print on a page. I don't know. Ooh. A relationship can be represented in multiple ways. A mapping illustrates, this is a mapping here where they draw, this is the domain, the X value, this is the Y, domain, range. It shows you draw the arrows, okay? You can do it on a graph. See, these are the 3 points. See, the point 0, 2 is right here. All right. Announcements. Okay. This is the relation, 3, 5, negative 4, negative 2, 0, 2. Every time I talk, he talks. Okay, the 4 ways you can write it. You can write it as a mapping diagram, as an XY table, a graph, or an equation. Okay. This is just the beginning of much fun to come, I tell you. Okay, all right. So example 1, representations of a relation. They're going to have us make a table, a graph, a mapping diagram, and determine the domain and range. They've given us this little set of points here, okay? So let's make this a table. Let's start with our XY table. And we have 2, 0. We have 0, 4. We have 3, negative 5. We need more table. Negative 3, negative 5. Right? We come down here and graph them. 2, 0. 0, 4. 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. Hope you guys all remember how to graph. And negative 3, negative 5. 1, 2, 3, 1, 2, 3, 4, 5. There we go. A mapping diagram would have 2 mapped to 0. It would have 0 mapped to 4. It would have 3 mapped to negative 5. And then you could do it this way. Negative 3 also maps to negative 5. I kind of ran out of room there, sorry. So determine the domain and range. Remember, domain, range. You say it first, it comes first. X is the domain, Y is the range. So the domain is negative 3, 0, 2, and positive 3. And the range is the Y values. Notice they only put the negative 5 one time. You only have to put it one time. It's cool. Okay, list the ordered pairs in each relation. Okay, let's see. What do they want us to do here? List the ordered pairs in each relation. Okay, so for the table, That's the table there. The ordered pairs are -1, -5. And then we have 4, 7. And then we have -2, 3. In the graph, we have 1, 2, 3, 4, 5, 1. We have -2, 1, 2, 3, 4, -2, -4. And we have -1, +3. Okay. In the mapping diagram, we have point 1, 5. 1 maps to 5. And then 5 maps to -1. And -6 also maps to -1. That's what you do for those. Pretty easy so far, right? Don't be fooled. They have lots of paragraphs waiting for you. Analyzing graphs of relations. So in this section, they're going to ask you to describe what's going on in the graph, or they're going to describe a situation and ask you to find the graph that best represents it. Okay, that's basically what all this says. It talks about independent and dependent variable. Almost always the independent variable will be down here. This is the variable that you choose. You get to choose this one. It's we're going to map days. We're going to map hours. You're going to map months, years. The dependent variable is the one that can change. It's the one that depends on these. Okay, so it's usually your y. Okay. And here's where they start having a million little fill-in-the-blank thingies, okay? So I went ahead and typed these up in advance and put them in here. So if you're filling this in your workbook and I'm going too fast, you can pause this video at any time and write these words in the blanks. Because I know you're going to go back and reread these for fun on Saturday, you know, with your friends, right? Okay. The graph represents the number of text messages sent by Nora throughout the day. Okay, so identify the independent and dependent variables. Okay, time is the independent variable is time. That's the y-axis here. This is the independent variable. The dependent variable is the number of text messages sent. Describe what happens in the graph. As you move from left to right along the graph, time increases. Okay. And the number of text messages also increases until the graph becomes a horizontal line. That must be when she was in math class and was too engrossed to text anyone. The horizontal line means that time is increasing, but the number of text messages sent is remaining constant. During this time, Nora stopped sending text messages because she was in her algebra class and she was having such a great time. Then she went to social studies and she continued to send messages until she finally stopped again for a period of time. Or then she continued to send some text messages and then she stopped and she began sending messages again. Okay, so they're talking about there's two level places. This must have been maybe she was eating lunch here. So she wasn't texting. This long one has to be math class. Yeah, that's and then this is social studies. Don't show this to Mr. Best, Mr. Helter. Come find me. Identify the independent and dependent variables of each relation. The average price of a ticket to an amusement park has steadily increased over time. So the average price of the ticket is the dependent variable and time is the independent variable. Oftentimes, time, days, years, those are your independent variables. The air pressure inside a soccer ball decreases with time. Time is the independent variable. Air pressure is the dependent variable. It gets better. Oh, this one's not too bad. I like these little guys. It's always fun to try to guess the right graph. Airplanes. After an airplane takes off, its altitude increases rapidly. Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the plane's altitude fluctuates slightly due to turbulence. Finally, the altitude decreases quickly as the plane lands. Which graph best represents the situation? I think you all can figure out that it's probably B. Yep, it's B. Because here we see the plane is taking off and gaining altitude. It flies steady for a while, and then they serve drinks, and it gets bumpy, so all the drinks get spilled, and then the plane lands. That's how it goes. Okay? Kane notices that traffic congestion on his street on weekday mornings depends on the time of day. He draws a graph to represent the relationship between the time of day and the volume of traffic congestion on his street on a weekday morning. This guy's really, he needs to get a life. Analyze the orange segment. Select the statement that describes what is happening during this time. Okay, so this is the orange segment they're talking about. All right. Traffic congestion is this variable, and this is time. And it looks like traffic congestion is decreasing here. Okay, so which one of these is decreasing? Traffic congestion is steadily increasing, not at the orange place. Traffic congestion is constant and light. No, that's down here. This is constant and light. Traffic congestion is constant and very heavy. No, constant and very heavy is up here. Traffic congestion is decreasing at a steady rate. Winner, winner, traffic congestion, chicken dinner. That's the one. That one. Okay, this part is kind of boring actually. When graphing on the coordinate system, the scale of a graph refers to the distance or interval between the tick marks on the x and y axis. So when they talk about scale, are you counting by ones? Are you counting by fives? Are you counting by tens? All right, and tick marks are each little line on the coordinate grid. That's what that says in English. And here's more fill in the blanks. So feel free to pause this if you want to fill in the blanks here. Okay, use appropriate scales. Step 1, the x coordinates are between, so we look at just the x values here. These are just the first numbers. All right, what's the lowest number? Negative 36. And the y and the highest number in the front is positive 38. So the highest and lowest x values. Then they want the highest and lowest y values between negative 91 and positive 95. So the x values need to go from about negative 40 to positive 40, and the y values should include values from negative 100 to positive 100. So they're saying a scale of 5 on the x-axis is appropriate, and a scale of 10 on the y-axis is appropriate. So this is going to be very hard to write this, but on the x it would be like 5, 10, 15, 20, 25, 30. Y, they're saying we have to go 10 at a time. So this would be 10, 20, 30, 40, 50, 60. And now they want you to graph those points. Well, I'll do one or two of these, but this is going to be really hard on this little graph. 580. Well, this is by fives, so that's 5. And 80 would be 10, 20, 30, 40, 50, 60, 70, 80. There, that's 580. Let's do this negative 10, negative 50, because these ones in between this graph is too small for me. Negative 10, negative 50. So we would go, come on, pen, cooperate. 5, 10, that's negative 10, and then negative 50 would be down 5. 1, 2, 3, 4, 5. And if you want, you can go ahead and graph the rest of those in your book. But no, I don't have time for that. I went too far. Okay, so the check. When graphing 1632, negative 10, 11, 4, negative 27, and negative 7, negative 5, select the most appropriate scale for the x-axis and the y-axis. Well, look at the x numbers. It goes from negative 7 to 16. So we need markings that will cover, negative 7 to, or no, negative 10 to 16 even. So we're going to have to go, let's see, let's go with B on this one. And the reason I want to pick B is because it covers the numbers and it has the smallest possible scale, okay? And nobody wants to count by sixes. It's easy to count by twos, okay? And then on the y-axis, on the y numbers, we have 32, 11, negative 27, and negative 5. So we go all the way from negative 27 to positive 32. So we're going to probably want to have one of these three here. But which one makes the most sense? A scale of 1, we're going to have 35 lines. Ooh, nobody wants to do that. Let's see. Oh, wait. Okay, we can't use this one because it doesn't have 35. We have to up to 32. So we're going to have to go with C then. We don't have 35 lines. It covers all the bases. We'll go with C. Are you having fun? Well, if you haven't had fun yet, this one's super fun. Okay. Choose an appropriate origin. Let the x-axis represent the years since 2005. See, because this chart starts at 2005 and goes up, we don't want to start at the beginning of time. We just want to start where the chart starts, okay? So 2005 is going to be the origin. And the y-axis represents the total snowfall in Boston. They should have made this Ohio. I guess this book's used all over the country, though, so maybe our snow's not as important as Boston's snow. The y-axis represents the total snowfall. The origin, 0, 0, represents the year 2005 and 0 inches of snowfall. So they're talking about the origin right here, okay? This is going to be 2005, and this is going to be 0 snow, all right? Graph the data points on the coordinate plane. Oh, well, we have to talk about the coordinates that we're going to do here. Choose an appropriate scale. The snowfall is between 1 and 43.3 inches, so the y-axis should include values from 0 to 45. Well, we don't have 45 lines, so they're saying let's go every 5. So this would be 5, 10, 15, 20, 25, 30, 35, 40, 45, and that gets it all in there. And then this is years since 2005. We're going to do this every one. This would be 2006, 2007, 2008, 2009, 2010, like that. So 2005... Well, they were going to call me, but they changed their mind. Okay, so 2005 would have 43.3. This is 2005, so we'd have 5, 10, 15, 20, 25, 30, 35, 43. Something is going to be like somewhere in here. 2006 has 8.1, so here's 2006, and you would go 5, and then most of the second one, so maybe about here. Oh, I'm not doing all of these. 2007 has 1 inch. Well, that's going to be way the heck down here. 2008 has 8.3 inches. So 5, 6, 7, about here. Okay, so you get what I'm doing, right? All right. I don't want to bore you to death. You're going, you've already done that, Ms. Williamson. Okay, example 5. Interpret scales and origins. The average number of posts per day on a social media site each year is given in the table. Interpret the meaning of the axis, scale, and origin of the corresponding graph of the data. So here we have year 2008 to 2017, and the average posts per day in millions. Wow, they're getting really a lot, aren't they? It's increasing by quite a bit. The x-axis represents the number of years since 2008 because it's not appropriate to start at the year 0. The y-axis represents the average number of posts per day in millions. So the scale, the x-axis has a scale of 1 mark equals 1 year. And the y-axis has a scale of 1 mark equals 50 million posts. The origin, 0, 0, represents the year 2008 and 0 posts per day. Except for they had 15 million posts per day. So they should, I copied their answers. That should have been 15. Yeah, it should have been 15. Stupid book. Here we go. Moving on. The United States Mint is responsible for producing. You think the Mint's going to go out of business now that everybody uses debit cards? Do you think we still need cash money? Or do you think it's just going to go to cards? I don't know. The United States Mint is responsible for producing and distributing circulating coins that are used by people every day to buy and sell goods. Facilities in Denver and Philadelphia produce billions of coins each year. The table and graph show how many circulating coins were produced each year at these facilities from 2001 to 2011. So, coins. How's the trend here? It kind of looks like it's going down. See, what I'm saying, not that many people are using money anymore, so we don't need so much. See, I was right. I didn't even know. Part A, interpret the meaning of the X and Y axis in the context of the situation. The x-axis represents years since 2001, because we're starting at 2001. It doesn't make sense to start at year 0. And don't even get me going on the BC thing, so no. And has a scale of 1 mark equals 1 year. The y-axis represents circulating coins produced in billions. on a scale of 1 mark equals 2 billion coins. What is the meaning of the origin? Okay, the origin 00 represents the year 2001 and 0 coins produced. You know what? Now that I think about that, I think they put it at 0 because they're asking you how do you interpret the origin? And so if it was this point right here, it would be 0 coins produced, which means on the one before, I guess it's kind of okay to have 0 here because the origin isn't that blue point, it's this point. So maybe they're not as dumb as I thought they were. Okay. So that is how you figure out how to number your axes and what the meaning of the origin is. I hope you enjoyed this little break from solving equations. I have not, because I really like solving equations. Today's secret video word is turkey. So when you go over on to McGraw-Hill and I have the secret video question for you, select the correct answer and it would be turkey. I hope you've enjoyed this video as much as I've enjoyed making it. I will see you in class.